The topic that we want to cover today is the graph of absolute value functions. Okay, so before getting into how we're going to do this, which is pretty straightforward and a lot of use of the calculator, we have four different equations here, and we want to determine which of them is linear, quadratic, absolute value, or exponential. It should be pretty clear. The first one is quadratic. The x is squared. That's the highest exponent. The second one is exponential. The x is an exponent. The third one is linear because neither x nor y are raised to a power greater than 1. And the fourth one is absolute value because you see the absolute value symbols. And recall that absolute value is the distance from 0 on the number line. So the absolute value of any number is always a positive. Now, an absolute value equation has a V-shaped graph and is a piecewise function. We talked about piecewise functions earlier in this unit, and when you see the graphs, I'll make that point again. The vertex is the turning point of the graph. And again, you'll see what that is pretty easily. Now, to graph absolute value equations, there's no real shortcut like there is in graphing linear equations where you can use the slope and the y-intercept and all of that. So the recommendation is that the simplest thing to do is to use your calculator. So I'm going to show how you do this with your calculator. We'll do the first two. Now you could easily create a table of values, okay, for x and then insert and figure out what y is. But I want to show you something, or you're going to see something in a moment that makes it clear that using your calculator is much easier. So we go to our calculator. Now, there's only going to be really one new thing in this whole process. We're still going to go to y equals. Now, the equation, and I'm just going to clear over those symbols there that were left over. Now, the only thing that's new in this process is that we're dealing with absolute value. They're already in y equals form, which is what we need them to be in to use the calculator. So the only thing that's going to be new for you is how do I get absolute value on a graph? Well, it's very simple. You're going to hit the math button, and the equation is y equals the absolute value of x. So absolute value is coming first. And if you look at the top, I have math number CPX probability. I'm going to go over to number, and you'll see the very first one is ABS for absolute value. So you're going to hit enter, and it brings up the absolute value symbols for you. And you're going to put in X, and you're going to hit enter, and you're done. Now, I want to go and look at the graph for a moment, which you can see down here also. And you'll see the graph is a V-shaped figure. And it's very simple as to why it is. If you look at the table of values, and let me just scroll this a little bit, what you can see is there's a repetition of y values, and it's just logical. -3 for x and 3 for x have the same absolute value. The same with -2 and 2, etc. So that's why you end up with this V-shaped curve. So what I'm just going to simply do is my vertex is 0, 0. That's the meeting point. And I'm just going to take the two extreme points of 10, 10, and -10, 10, and draw my. Recall that it's called piecewise because it's made up of more than one line. Now, we'll do the next one on the calculator. And I'm going to keep the old one in there. So we're going to go back to y equals. Now what we want to have is we're going to hit math. We're going to go over to number, call up absolute value. And now what we're going to have is the absolute value of x plus 2. And I want to take a look at the graph. And if you notice what's happened, our original graph's vertex was the origin. This graph has moved 2 units to the left. And you might say, well, why is that the case? Well, that's the equivalent of our x-intercept. And if we call up the table for that one, when x is -2, y is 0. Okay, and you don't have the matching anymore. In other words, 2 is 4, not 0. Okay, because of how the equation works. So in graphing this one, I'm going to graph the vertex of -2, 0. And the other 2 points I'm going to graph that match up are -10 gives me 8, and 6 gives me 8. All I'm trying to do is keep my graph symmetrical. Okay? My vertex is -2, 0. And what really has happened here is, if you take a look, these are the exact same shaped figures. All we've done, if you might recall from your prior years, the transformation concept of moving shapes, we've translated the figure 2 units to the left. Okay? So all we did was take the original and shift it 2 units to the left. Okay? Now I'm going to do one more on the calculator for you. And then the others, I'm just going to plot up the points. All right? Now I have the 2 outside the absolute value symbol. Okay? So I'm going to go back. Okay? I'm going to go y equals. I'm going to put a third one up there. I hit math. Go over to number. I hit absolute value. I'm putting x in there. Then I have to move my cursor because the +2 is on the outside. And I want to take a look at the graph. And now you'll see what has happened is that the figure has moved 2 units up. And that your vertex here for the third one, so I've got to scroll this over, is 0, 2. Okay? And you can see it's like right in the middle where the numbers start to repeat. So for that one, I'm going to graph my vertex of 0, 2. And we're going to recap what's happened with all of these. And then you'll see that 8 yields 10. And -8 yields 10. And I'm done. Okay. Now, I have absolute value of y equals the absolute value of x minus 2. Well, if x plus 2 shifted it to the left, this one's going to shift it to the right. When I'm at 10, I'm at 8. And when I'm at -6, I'm at 8 also. And you'll see everything is staying symmetrical. Okay. Now, what I'd like to do, just to show this and highlight this to you, this next one I'm going to do, or even the next 2 I'm going to do on the calculator. So let's go to y equals again. I'm going to leave the original one in there so we can contrast them. So this one is the absolute value, or y equals 3 times the absolute value of x. And let's see what happens to our graph. There's the original, and there's the y equals 3 times the absolute value of x. So now what you can see is that the graph has contracted, okay? And so the points I'm going to graph are 0, 0 is my vertex still. When I'm at 1, I'm at 3. When I'm at -1, I'm at 3. There's my symmetry. When I'm at 2, I'm at 6. And when I'm at 3, I'm at 9. And -3, I'm at 9. So what you'll see is your figure, and it's not a very good drawing, contracted. Now I want to do y equals the absolute value, y equals 1/2 the absolute value of x. So let's see what that does to our graph. So I'm going to go in, and what I'm going to do here is change the 3 to 1/2, so that's 1 divided by 2, math, absolute value, x, and now let's see what happens in our graph. There's the original, and now logic should tell you that this is going to get much wider. And again, it makes sense because the larger the numbers, as my numbers are inputted for x, they're getting smaller for y, so it expands out. So at 0, 0 still, at 2 and -2, I'm at 1. At 4 and -4, I'm at 2. And this would go all the way out at 10. I'm at 5. And at -10, I'm at 5. And there's my symmetry. Okay. The last one I just want to show you what happens if the coefficient in front is a negative, and this would mean it's a coefficient of -1. So let's contrast that one, call up my graph. So remember, when you're putting a negative in, it's the negative sign underneath the 3, negative, math, enter. Wait, let me just clear all this. Negative, math, enter, 3. Why is it coming up with a fraction symbol? All right, y equals negative, math. Oh, that's why. Move it over to number. Absolute value of 3, x. Now I want to see what those graphs look like. There's my original that always graphs first. And now you can see it's flipped the graph upside down. So my vertex is still 0, 0. But now when I put 1 in for x, I get -3, and the same for -1. When I put 2 in, etc. So I'm going to go to 3. At 3, I'm at 9. At -3, I'm at 9. There's my symmetry right there. Okay? Note that 2, 3, and 4 are translations of 1. In other words, same size and shape, congruent figures, just moved by sliding. That's what a translation is. So let's recap what happens in absolute value. When there's a number being multiplied in front, all right, 3 things. Number 1, a number whose absolute value is greater than 1, it contracts the figure. Okay. Number 2, a number whose absolute value is between 0 and 1 expands. That was what the 1/2 did. And then 3, a negative number, it opens downward. Now, again, once I go through all these rules, I'm not expecting you to memorize the rules. You should be able to see the before and after when you do the graphing. Okay? When there is a number being multiplied inside of the absolute value, what happens? The same as 1 and 2 above. Not 3, because if there's a number that's negative inside, it's going to end up turning positive. Okay? Now, when there is a number being added inside of the absolute value, you should be able to tell me what this happens here. If added, it shifts left, and if subtracted, it shifts right. Okay? And you're thinking about it as what's the value of x that makes my answer 0? Okay? And then the last one, when there's a number being added outside, if added, move up. If subtracted, move down. Okay? Again, I'm not expecting you to memorize all these, but I am expecting you to be able to understand if you are asked what happens if you do this or that, that you should be able to come up with your own example to answer the question. Now, the last thing I want to show you in terms of these piecewise functions is what's called a step function. A step function is another example of a piecewise function that pairs every number in an interval with a single value. And you'll see why it's called stepwise in a moment. So let's take a look. A school will charter a bus so that the student body can attend a football game. Each bus holds 60 students at the most, and want to make a graph that shows the relationship between the number of students going to the game and the number of buses needed. Okay? Well, first thing you should understand is that the x-axis is students, because the number of students generates the number of buses. Okay? And I'm going to go in intervals of 60. Well, technically 30, 30, 60, 90. I'm just going to write them in intervals of 60. Okay? And then here's the number of buses. Now, if I have no students, I don't need any buses. If I have anywhere from 1 student to 60 students, I'm going to need 1 bus. Okay? If I have anywhere from 61 to 120 students, I'm going to need 2 buses. Now, you might say, why am I putting the open circle? Well, this is showing me the steps. At exactly 60 students, I need 1 bus. And the way to just depict this is my open circle, similar to what you saw with graphing inequalities, tells me 60 is not part of this, but everybody from 61 to 120. Now, the steps are just going to continue. And you're done. And again, it's called a step function because it looks like steps. Okay? So, two things covered today: absolute value graphs, which you'll mainly use your calculator to deal with, and step functions. Both of them are examples of piecewise functions.